All right, so here we have our Ansys workbench. This is going to be our project. We're going to start out with static structural, and then we're going to add in eigenvalue buckling, and we want to share the engineering data for the materials properties, the geometry of our part, the mesh, and we also want to share our solution. Okay, so we got to go down the list and make sure everything's all checked out in green. Let's go ahead and start with our material properties. It started us out by default with structural steel, but I'm going to show you how to get there. We actually do want structural steel. In our engineering data sources, this is a library with all sorts of pre-filled materials. What we want is just under general materials, and there's structural steel. And we want to make sure that our structural steel, when we close our library and we look at our material properties, we want to make sure that our Young's modulus is 200 GPa. And so this is 2e to the 11. We wanted 200e to the 9, so this is correct. Okay, and while I'm here, I'm going to make sure our units are in metric and also displayed in our project units. So that way, throughout our project, it stays in metric and we don't get confused. All right, so going back to our project, our engineering data has now been set. We need to get our geometry imported. Now you can do this through Ansys, but I rarely do, so why relearn something when you already know how to do it in SolidWorks? Okay, so now in SolidWorks, let's go ahead and make our single simple piece, and for this project, we'll just make it a seat post. All right, so we're going to start with this top plane. There's our outer diameter. Here's our inner, and let's get some dimensions on that. I believe a standard seat post is about 1 inch. I know we're working in metric, I know. And let's go with a 1 millimeter wall thickness, which would give us this as our ID. Okay, now we want to extrude that. And let's go ahead and do 250 millimeters, about 10 inches. I think this is enough length for us to see some buckling. Let's go ahead and save this. Seat post. I'm gonna save it as a step file to make sure it opens correctly in Ansys. Okay, jumping back over to Ansys, we now need to import our file. So under geometry, we can import. I want to make sure it's the right one because I have some practice files. There's our step, and this is the time that I'm doing it. Yeah, a day before it's due. How about that? All right, so now we got our geometry. We're going to go to our model. This is where we're going to tell it our boundary conditions as well as our mesh sizing. And it's starting mechanical right now. All right, looks like we're good. Okay, so first off, geometry has a question mark, and the material needs to be assigned. There's our structural steel, so let's go ahead and label that. And now we have geometry with check marks. Our mesh needs to be defined, but I do want to do that after my next steps because it's a little bit easier to select faces when the faces are just one face instead of many elements. So I'm going to go ahead and go to my static structural, and I'm going to insert our force. This is going to be our downward force. Panning is a little difficult here. I'm going to select this face and hit apply. So this is the face that we will be applying our force. We want to apply our force in the downward direction or the negative y-axis. To make that easier, I'm going to go ahead and click, instead of by vector, by components, so that I can specify which direction. And I'm only going to do -1. That reason is because when we get our answer is going to be in the form of safety factor. And the way that the math works out, if we used 1, then multiplied by our safety factor, which is probably going to be 45,000, then 45,000 as our safety factor is actually how many newtons we need, or is our F critical, or critical force before we see buckling. Okay, so the other thing we need to do is we need to fix the other side. Let's go ahead and insert a fixed face. I'm going to go ahead and go down here and select the bottom face. Hit apply, and now this is now fixed. It shows up in my little feature tree here. All right, so our solution, what do we want out of this? We want our deformation, our total deformation. And we're also going to do that under our eigenvalue buckling. And this lets us see how much deformation there is and which direction the buckling is. There could be multiple modes of buckling, so this will show us which we get. All right, so next thing we need to do is mesh. So let's go ahead and click on our mesh. We could technically go ahead and hit update, which will generate the mesh, and we can see what we get. If the mesh is too coarse, we might want to refine that. I think this is actually pretty reasonable, but just for the sake of it, let's go ahead and increase the resolution of our mesh just a little bit. Could help just a baby bit. I believe that's it. Okay, let's go ahead and update our mesh. There we go. I'm using multiple years of Ansys here, so it's a little difficult. The UI has changed quite a bit. All right, so I think the mesh is fine enough for what we're trying to do. I think we also have everything that we need. So let's go ahead, and you see these little lightning bolts. That means it needs to be solved. So I'm going to go ahead and click the solve button and see if we get what we want. I see green check marks. That's always a good sign. Now, we already did this on paper because we want to know what the answer is going to be before we do it, so that if we get some crazy number here, we can tell you that it's wrong and we need to fix something. So earlier I said 45,000. I think we calculated 45,100 or so. And we just got a load multiplier right here of 44,683. So that's a very small error, maybe like 1% or so. So it's well within reason. And I think that we entered in our data properly and we have at least a solution that makes sense. So this is our animation, which shows our deformation and which direction that we buckled. Let's play around and see if we can get a different mode. Did we get 2 modes? This would, maybe we didn't solve for 2 modes. Let's try and do that again. This would be if you have even more force, what would be the next way of doing it? I see down here mode 1 and mode 2. These are both at the same load multiplier, so it looks like we only have one mode of buckling for this particular example. Sometimes you can have like an axial twist or something like that, but that makes sense with this tube shape that you're probably not going to worry so much axially. It's going to show up much, much later as a mode. All right, so I think that's just about everything. You also have solution information here that you can print out if needed. It's probably going to show us our multiplier somewhere in here. Solution. There's our load multiplier. There's our mode or shape number. So we only really have one mode, and it's at this 44,000 kilonewtons. And we went ahead and verified that with our handwritten math, so everything checks out.